quick intro, quick plug for upcoming events. But welcome everyone. Today we've got Alec Brunel. This is the I think 5th LogRocket meetup. We're just trying to turn our kind of blog content into life. These have been going great. If you have any feedback on this session or want to hear about other topics or more about this topic, shoot me an email at luke@logrocket.com. Yep, today we're going over the URQL library, which is a seemingly pretty cool Apollo alternative for GraphQL client. And yeah, so we've got some other meetups coming up. We've got a TypeScript alternative using JSDoc, which we'll see how that goes. I don't think it's a real alternative, but that's kind of the talk, I guess. Then we've got another GraphQL one coming up using GraphQL CodeGen. That's on December 7th, so in a couple weeks. And then React versus Next, kind of just general broad overview meetup in later December. We'll be adding a bunch more there, so you can sign up for these on the blog at /techmeetups.com. And then real quick, this is obviously this meetup is brought to you by LogRocket. And I'm the director of growth there, by the way. And yeah, I just wanted to quickly, LogRocket's a front-end monitoring solution. Wanted to quickly show just kind of how we use LogRocket in our own product to go monitor our GraphQL endpoints. So yeah, this is our metrics kind of view, and basically LogRocket monitors every single person in production. And you can go say like, show me all GraphQL requests with the status 0, or the body, contains session query, and then go see how that, we obviously don't want that status code 0, very bad. You can go see all the people that were affected by that. So this is kind of the view of the session replay, and you can see this person's trying to log into LogRocket. Then we can go find the failed request here. So that's our GraphQL endpoint. And you can go check out like the actual query itself, the request, the response, the keys and the variables, and just be able to really debug GraphQL a lot quicker. So thanks for sticking through that. Alec, I'm going to pass this off to you and you can share your screen.
Okay. Let's go up here.
Yeah, if anyone has any questions, just throw them in the chat and we'll either get to them at the end.
Yeah, sure. I was going to say that too. Yeah. Well, yeah. We'll take some time at the end to do some Q&A. Yeah, so thanks for coming today, guys. Here is the talk title, using GraphQL and the URQL library. I don't know if it's your URQL or URQL. So I'm going to say URQL just to be pedantic, but so to build advanced features on the client side. So really quickly, who am I? My name's Alec Brunel, software engineer at Unity Technologies right now, currently. And I'm working with GraphQL APIs mostly, but sometimes I'm peaking my my experience with React and front end still. My previous jobs and employment have been mostly React and GraphQL, so that's where I got a lot of my experience with, particularly with Apollo Client, and I'll speak on that later. So for the agenda today, we're gonna start with a very quick GraphQL primer. I know that probably some people here are experienced with GraphQL, but it's mostly just a little primer that sets us up for the rest of the talk. The next thing is going to be taking a look at actually URQL as a library itself, sort of what are the advantages there, like why are we picking that today? Then we're going to get into client-side caching strategies and then question and answers. So I sort of have 3 questions sort of presented for the audience right now. And maybe if you want to put it in the chat or something, or raise your hand, or basically just want to say, if you're familiar with GraphQL, how familiar are you with Apollo Client? Have you ever heard of URQL at all?
I can go first. I'd never heard of it until we spoke.
Oh, really? Cool. Okay, cool. I'm just looking at the chat here. Spencer says, Yes, yes, and no. Okay, so you have someone that's very, so yeah. So, I mean, Luke, today, you already showed GraphQL, so you're already experienced a little bit with GraphQL, and might have heard of Apollo client and stuff, but not a lot of people are probably going to be very knowledgeable about URQL. So let's frame our mind with that. Okay, the slides again. So very quick explainer with GraphQL here. Basically how I like to see it as basically a very well-defined API contract between the client and server. And this lets you do a lot of cool things. This is very different from previous sort of interfaces you've had between the client and server. They've been very convention-based, and sometimes they've been all over the place. Let's say with REST, right? There are a lot of different ways to interpret that. So with GraphQL, you have a very well-defined contract and a language that lets you describe that data. Here's an example, a very small, simple example of a GraphQL schema that we're going to use for the rest of the talk. This one lets you query for a user by their ID. This has name, email, and you guessed it, we're gonna look at a to-do app today because that's very simple and easy to understand. So with that to-do app, we have a user and they have to-dos on them, and to-dos have descriptions and they have a Boolean to say if they're done or not. We also have a way to update to-dos with a very simple mutation here as well to say, please update my to-do as done. So the thing that GraphQL sort of enables when you have this sort of schema is a couple of different things. The one thing that really is nice about it is data discovery. So you have a very easy way for people to understand, oh, how do I get this data? How do I get that data? Very quick shout out to sort of thing like Apollo Federation or Federation Spec that lets an entire organization have one GraphQL schema, which is very powerful. Something I'm going to be doing today is like mocking an API server with GraphQL. That's very easy to do because the entire thing is typed and mocked. But then the very important thing that we're going to talk about today with our caching strategies is entity relationships. And this is how, as you saw before in that GraphQL schema, we were able to define a way for to-dos to be related to users in the contract itself, which is very, very powerful. And that's sort of what can lead us to these really nice caching strategies. Libraries that can handle caching strategies for us. So very quick sort of speaking here on the ecosystem a bit. Because of this, because of GraphQL and its specification, we can have libraries that do much more for us than traditional sort of API clients, as you'd say. So they can handle sending queries, they can handle caching, they can even handle state management for us. Apollo even has a thing called Apollo Local State that I've worked with in the past. And these are all kind of abstractions on ways of things that people might have done before manually, maybe with some boilerplate, maybe they've done it very custom to their system, but because of this GraphQL API contract, we can now put a lot of that logic into these libraries. So these are sort of very popular ones. I'm going to speak on them later. So to sort of set up the rest of the talk, we have this design of our to-do app, and this is something we want to accomplish by the end of the talk. We want to get this thing done. So we're handed this design by our incredible designer at our company. They're saying, please make this to-do example app. We want the user info to be on there. We want our to-dos to be displayed. And because we have that GraphQL schema before, we know that this is all can be done. All the fields sort of line up. So the next thing in our life cycle, we have this GraphQL schema, we have the API, we have the design, and we're a front-end developer. Okay, let's pick a GraphQL library. So as I said before, it's pretty important because there's going to be a lot of things it can do now for us, where before if we didn't have GraphQL, choosing like Axios or like a request itself, like these are not extremely integral things to your app, but this is very integral because this is going to be doing a lot for you. Something I didn't even put here is error handling. It can do a lot for you. So it's very important. So traditionally, I would have been Apollo client. I have lots of experience in Apollo client. A super popular solution. There's nothing, I would not fault anyone for choosing Apollo. They have some pretty good SaaS products out there that help you with GraphQL and stuff like that, if you're into that. The one con I'm seeing is basically based on my experience with that, getting into sort of a very heavy caching solution with Apollo was pretty complex, has a pretty big steep learning curve, and kind of does a lot without telling you what it's doing. So it's kind of unclear. Docs are not the greatest on this, so that's something I found. And another thing I found too with Apollo is that they're not really focused on making like the best open source tooling. It's kind of like a second priority to like their SaaS products. So I just wish they were a little bit more into giving the maintainers of the repos a little bit more control, because there's just been issues that I've wanted addressed for so long, like we're talking years here. So that's my very quick rant on OpenCore that I'm not going to get into. But so earlier this year, like just as an aside, like I was looking at different GraphQL client libraries to go and choose. Because I had a project coming up where it was kind of like a greenfield project that I was going to introduce and teach a team how to introduce GraphQL into their React app. So they could have picked anything. And I was looking at Apollo, I looked at React Query, that's the one I showed before. And then there was URQL on the side. And so I started looking into that one. So after finding it, I was like, okay, this is awesome. There's a couple different reasons, really high level, like why URQL makes a lot of sense. It's a decent following, probably not the most, like it's not going to have the same downloads as Apollo client, maybe not ever will, just because of how far of a lead Apollo client has, but it has a pretty decent following. Lots of people are using it these days. The one really cool thing about the caching solution, which I really liked, was that it actually defaults you to something called a document cache. This is different from a normalized cache, and Apollo client only gives you normalized cache. This is where sort of I saw the differences happening, which I really liked. And we'll talk on those two later on. The next thing was, it was much more community focused. So they have a lot more going for them in this regard. Like there are a lot more, it's run by a company called Formidable that is more of like a contractor, sort of like client-contractor relationship business firm that spends a lot of time on open source with a lot of different packages. So they kind of know what they're doing there. It's much better maintained, I found. And as a result of this, they even do some first-party packages, which I really liked, that Apollo client doesn't do. So that's another thing that I saw was like, okay, wow, this is really nice. They do some things I wanted to do myself and haven't had time to actually write and do, and then they did is go ahead and make a package for it. And they not only that, but they maintain it as a first-party package, which was really nice. So here's a very quick URQL example that we'll go through really quickly here. The client setup is very similar to Apollo client. I think you can do this pretty much the same way. You just pass in a URL. Here's our mock API that we're going to use today. You wrap that in your main app, in your main React app. Throw in that provider higher order component. And then this is very similar to something like you've seen in Apollo client as well. Like we're using our use query hook, passing in the query document, and we're just going to display that on the page, not for the user to do. So here's the demo. On the left here, we have us hitting the mock API endpoint, see the data coming back. We're like, okay, all good. On the right, we have our mock application. We refresh the page. Okay, everything's loading in. Everything's good. So far, everyone's pretty happy. So what happens is the next step in the software development lifecycle happens, and the user feedback is saying that these user to-dos, they're loading slow now. All of a sudden they got slow. You investigate it yourself. You see that the API is now returning it much more slow. And you're saying to yourself, okay, we got to do something about this. Not only that, but product the product team or product management at your company comes to you and says, hey, we want user to-dos to be on multiple pages in the app now. We have one app, we have one page right now, but we want multiple pages in the app to query the same data. And you're thinking to yourself, oh, wow, okay, so this is not only is it a slow API, but users are now gonna have to query for this in multiple places within the app. So you're thinking to yourself, okay, let's look at caching. This might make a lot of sense for us. So currently, right off the bat from our client setup before, we already got the document cache built in. It comes with URQL by default. And this is a great first step. So here in this demo here, we have the same thing as before, except I put a button on here that basically simulates navigating to a different page. And all this is doing is refetching the data, like it's just calling the query again. And as you can see here, there's no network request happening. So I refresh the page. Okay, that's when the network request happened. But when I navigate the page, navigate to a different page, no network requests are happening, which is great. This is sort of what we wanted, and might solve our problems. So how the document cache a little bit on how it works is it's very aggressive when it comes to busting that data. And when I say bust, I mean invalidating, I mean taking the data out of the cache. So once that query was done initially, so here's an example of books, but you can think of to-dos as the same way. We queried the to-dos from the API, and that was put in the cache. And once we navigated around our app, URQL knew, okay, hey, the to-dos are in the cache, let's take them out. Or books are in the cache, or users are in the cache. They're already there. Let's go take those out. But the thing is, that cache data is not live and up to date with our API. So we need a way to take that data out and put it with new data if the user or anything else happens that would create that data to be stale, to be not up to date anymore, and that's not good. So one thing that document cache does, it tries to aggressively bust that cache. So here we have like a like book, or you can think of like a done to do mutation. And because that mutation response has the type name inside it of the data that's in the cache, URQL is saying, hey, none of this data anymore is valid. Let's go and make a new query. So it's very aggressive. It doesn't look at any IDs, it doesn't look at any other properties. It's very simple, as in like, oh, you mutated some data that has to do with this data type. Okay, let's just take out everything in the cache. Let's go query the API again and get that new data. And so I'll show an example of how this works. So here's our example mutation. I hard-coded the values here, like basically saying like update the hello world to done. And this is what the mutation I'll use for the next few examples. So here on the left here is me simulating that page transition again. And here's something here too that I'm demonstrating is the URQL DevTool extension. And this is similar to the Apollo client one, except I think this one's designed a bit better too. That you can see the cache outcomes as you navigate through the app. It records, is it a hit or is it a miss? You can see here, like on the left, the to-dos were actually cache hits when I refresh the page here, or when I navigate to a different page. On the right is where things get a little interesting. I made a button on the app that triggered this update to do mutation that we showed earlier. So when I click that, you can see how it makes two requests now. It makes one to do the mutation itself, to change that data. And then it's doing another graph. It looks like 4, but it's actually 2. But so that I look at the second one. And that network request URQL is doing automatically for us and busting the cache and making that original query before to go and get that new data. So it results in another network request, but it's happening in the background, and it's basically making sure that our cache is up to date. Certain level. And here's what this is a very contrived, simple example of what the document cache looks like. It doesn't actually look like this, but it's much easier to understand when you look at it this way. Document cache is basically just saying, hey, I'm going to key, my cache keys are just the queries that my app has made. And so we had that query before, get user data, that was like user and to-dos. It would just put get user data as a cache key, and then put the user in there. And this is just like the straight response from that query. So looking at our caching strategies choices, we've gone over document cache a little bit. We've seen that the cache keys are based on the query plus the variables. I didn't use any variables in this one, but it would use that in the cache key as well. And it invalidates all the data when that mutation result comes in with the same type name. And that's what from our demo before, because that our mutation had type name to do, URQL knew, okay, I need to go make that new query, or I got to make that old query over again. So this is where we now take the next step and we say, let's look at normalized. And I'll go over like normalized a little bit more. Why would you use it? All that jazz. But how normalized differs is the cache keys are based on the entity IDs. So this is it's taking a next step further approach to things where it's trying to be a little bit more smart. Instead of being so aggressive with our cache busting, we want to make the cache all entity based and say, hey, if something was updated, only update that one thing in the cache. So it's invalidating only the data that is updated in the mutation result, not all the data, which is different than how document caching works. So before we move on, this is sort of what goes into like why I like URQL so much, is that it gave you the option of document caching in the first place, which is actually very good for a lot of people. This can be a very good solution for a lot of apps. APIs that might not be that slow, they might be fast, so it's actually fine for the user to have that aggressive busting. It's very simple. It came default right with URQL. We didn't have to configure anything, and it knew what to do. So that was very nice. So before we move on to normalized caching, we have to sort of understand, okay, we're going to stick another burden. We're going to have some more burden with this because you can't guarantee normalized caching to work all the time for every use case. They're often a little bit more complex, a little bit more things, like even comparing URQL and Apollo clients, normalized caching strategies, they're pretty similar, but URQL is a better way of documenting it. So we kind of have to take that on. We have to worry about data invalidation. This is caching in general. This is not really just caching with front end, but just the caching in computer science or just apps in general. Like people joke that that's like one of the hardest problems in computer science is caching. So we have to worry about that. And there's other constraints from our GraphQL APIs that we need to worry about. So there's relay is like another layer on top of GraphQL, and they strictly say, hey, provide IDs for entities in the GraphQL schema. But some GraphQL APIs may not require this, may not get into that. So we need to be worried about that a bit. Not all GraphQL APIs are exactly the same. They have a certain standard, pretty high standard, but they're not. Sometimes they might not work for a normalized caching strategy. So exactly how the normalized cache will work is it's updating the data in the cache. So as I said before, based on the mutation response ID, and it's going to update just that one entity. So it might actually, it's going to save us network trips. The thing is that as I said before, some GraphQL APIs might not have ID in their mutation results, or they might even not have any entity data in their mutation results. They might just say success, okay, done. Or they might have some side effects, and they might actually mutate other data that is in your GraphQL schema, that is in your cache. So you have to worry about this much more, because potentially what happens is that you start giving your users invalid, stale data, which is never good. And then lastly, like what I said, what this kind of alludes to is that there's less network requests potentially than the document cache, because we're not having to go back to the API, grab new fresh data all the time. So here's an example of the normalized cache structure. And you can see that this is already different. It's taking all the entities and bringing it to more of the top level. We have our user here as before, except to-dos are not under there anymore. There'd be like some sort of reference key to say, hey, to-dos are at the top level and to-dos are over here. And how that sets up is URQL is now going to go in and say, hey, only update the single to-do. The single to-do was updated from done from false to true. Only update that. Nothing else in the cache needs to get touched. So setting up the default normalized cache in URQL is quite simple as well. This is like just passing it with no arguments. It does a lot for you right off the bat. But obviously there's different options and more configuration that you can get into if you like. And here's a demo of it working. So I didn't really change any code really. I just set up the cache, the normalized cache. And on the left here, I'm simulating that page transition again. And we can see how it's just still hitting the cache. All that jazz is working. On the right is where things are a bit different. So when I trigger that mutation again, we see only one GraphQL request go out now, not two. Because that first one, that mutation actually just goes back, and actually just updates. And you can see here on the bottom too, the to-do, that to-do is updating in the UI because URQL was able to get that mutation result, got the done from there, and was able to just update that one single part of the cache. So what this kind of gives you is based on this, URQL now builds on that and starts giving you like a lot more other features that potentially could be interesting for you. So we have optimistic mutation updates. This is something that a lot of your GraphQL libraries can do. You can actually just specify, okay, this is what the response will probably look like. You can think of like a tweet, right? When you like a tweet, you know that it's going from like empty heart to heart. You know that the UI knows that, so you can give the user that feedback first, and then kind of do the network request and cache update in the background. You can even use it for app state, so you can implement some custom field resolvers and updaters to manipulate the cache in a custom way, like a completely custom way, which could be useful for you. And also there's offline support. So this is kind of like, well, I'll go into this. I have an example of this after, but basically if your app, all of a sudden the user's internet connection gets cut, but they're still able to navigate through your app because you still have this cache, maybe locally stored on your browser somewhere. So here I just go a little bit into the offline support and how simple this is as well, which is really nice. I added the offline exchange npm module from URQL. And I say the storage is make local storage. I go to the top here and I just have to define two functions. How to interact with the local storage of the browser. And this is actually just writing the full cache to the local storage every single update and on every single read. And sort of this is what it can enable. So on the left here, I have, you can see here, as I was navigating through my app, I look at the local storage and I see the whole cache is in there, which is nice. Okay, that's working. And on the right, I disable or I block the GraphQL requests to see, is my offline support actually working? And as you can see, it is working. I go to navigate to a different page, I refresh that data, no network requests are being sent out, and I'm able to actually still get that data. Nice. The next thing is I just want a quick shout out because I could have gone into like multiple other exchanges, but basically the theme here is that the other ones are great as well. There's one fully dedicated to authentication, which is really nice because in Apollo client, you kind of have to do this on your own, but it kind of gives you some patterns to know when like a user's logged out, logged in, and stuff like that, which is really nice. Also, there is SSR support with Next.js, sort of like first party built in, which I thought was really good too, because this was also another thing we had to do custom in the past. So yeah, so for the conclusion, I would say go for document caching first. There's also some request policy tuning you can do even with this. That could be very useful to you. And that could be that could actually get you pretty far. I would say if you have a very slow API or you have like a huge data heavy app that requires some very, very snappy response times, then maybe dip your toes into normalized caching, see if it's right for you, see if the burden and the GraphQL APIs that you're interacting with, if they support things out of the box, or you're going to have to write all this custom code to sort of like update your cache. Yeah, so I hope you enjoyed the talk today. And does anyone have any questions or that I can talk to about anything I talked today, anything about GraphQL, anything about URQL in general? It doesn't have to be just about exactly what I talked about today.
Seems like now I've got one. So like when you work with normalized caching and you're trying to, do something custom for cache management, how do you interact with the request IDs? Like where does that happen? Is that like within the client? Like,
yeah. So it's actually within the client. There's basically configuration you can put onto your client that basically says, hey, if I have these for these types, if I see these types anywhere within the request lifecycle, so if I see them in a mutation response, and my GraphQL API doesn't have an ID in it, you can say, hey, don't base your ID on ID, base it on maybe something else. So this is like if you have no interaction with the GraphQL API, like you have no control over it, and maybe this GraphQL API is like living somewhere else, like it doesn't even live within your organization.
Right.
And you can kind of say like, you can make your own. Maybe you know that name and UUID or UID is, or maybe you have UID, maybe you have a different one. You can specify exactly there, hey, use this as a key. And URQL tries its best to use this as key going forward. Yeah.
Cool. So yeah, that gives you a lot more control, just generally. Yeah, this is cool stuff. I'm used to I'm still in like varnish land from years ago. So like this is like a million times better.
Cool. Yeah. I think I've seen that a bunch of times, is that there's a lot of APIs out there that don't have ID sometimes, but you can infer one maybe on name and some other property. You can combine them even. You can say like, it's kind of like a compound key.
Mm-hmm. Awesome. Well, there's no other questions. I'm going to post this up and send the recording out. And yeah, thanks a ton, Alec. That was really interesting.
Yeah, no problem. Anytime.
Cool.
What was useful.
We'll see you soon.
Yeah, talk to you later, right?
Bye.